a cube and a sphere, both with a scale of -3 on the y-axis. So I'm again going to pause while I set this up. So I have set up the extreme data. As you can see, there's a sphere with a scale of -3 along the y-axis. This has not worked as I expected. This has actually created something of, I'm not even sure what shape that is. But for the cube, it has worked. It is the same as if I were to scale it by 3 along the y-axis. As you can see, I've changed it to 3 and there is no difference. So, moving on, the next test is testing that changing camera settings results in a different image besides changing the resolution. So again, I'm going to set up the scene quickly while I pause. So here for the typical test, it starts with a camera of no rotation, an aspect ratio of 4:3, which I will change now to show it working. Currently it's set to 16:9, which is the default, but now it is 4:3. As you can see, that has changed the dimensions of the image. Looking at, and no depth of field, as indicated by the blur being 0. And as you can see, this is working just fine. Test 2, the camera looking diagonally down at the same cube with an aspect ratio of 1:5, depth field of approximately 0.5 blur, and distance just before the cube. So the blur being set to 0.5 has blurred the image. I'm going to export this quickly just to get an easier view of the image. As you can see, we're looking diagonally down. It's been blurred slightly due to the depth of field, which shows that this the two typical tests pass. The next test is testing that the render can take into account different materials for each object or shared materials. So the typical test here is testing that every object uses a material set to give off white light. Second typical test is one object gives off white light, the other is set to a matte green. So I will pause again while I set up the data for this. So I'm back. I've set up the scene with two distinct spheres. I am now going to change the material to give off purely white light. So no reflection, so no need for base color. And a fully emissive image. So if I hit render, I'm going to first decrease the resolution again for the sake of time. It can sometimes be quite slow to change between objects. If I hit full render, and give it a sec to load. I'm going to pause and come back when this has finished loading. So the image has finished loading, so I'm going to save it. And when it comes up, it should see, yep, two white balls, as both are emitting white light, and there's nothing reflecting it. So for the second test for the typical data, that involves changing one of them to a material that is showing matte green. So if I add a new material with the emission all the way down, I will change it to matte green, which will be 00 FF00, and I will change the second smaller spheres material to that second material, and now I'll hit render again. And again, I'm going to pause it while I wait. So the image has just finished rendering, so I'm going to save it again, just as test image again. Hopefully we should see the big sphere as white again, and then some hint of green. The resolution is very low, so there might not be too much green. There should be some hint of green. There it is. Green there. If the resolution was higher and we were using higher samples, which I'm not doing for the sake of time, it would be much more evident that there is green on one side where the light has been emitted from. So, typical tests pass. So, the extreme test here is that each object is set to be non-emissive and each has a different color value. So I can change that very quickly if I go to the first material and change that to have the emission all the way down again, and then I can input a random color here, such as 45F07A, which is a random color. I'm not even sure what color that is. And if I hit render again, which again I will pause the recording for, we should see, in theory, a black screen as there's no emissive textures, materials. So the image has just finished rendering again. So again, I'll save it. And we'll see, as we can see, it's a fully black image because there are no emissive materials. It shows the typical and extreme pass. The last test in the main algorithm and processing section is testing that specular reflections result in a different color when it is a specular reflection. So we only have one test for this, a typical test, testing using a white emitting sphere and a second sphere with a base color of 00FF00, so matte green as before, and a specular color of full white. Perform the render with 0 roughness and with 1 roughness. So I will go back to using the fully emissive and matte green textures again. As you can see, the specular highlight color is already 0, FFFFF. So if I hit render again, which I'll pause for, we'll see the image we saw before. So once again, the image has just finished rendering, so I'll save it. As you can see, as we saw before, it's slightly different this time. We have a white ball and some green showing the reflections. So I will now change it to be fully reflective. So we should see that it's that green is overwritten with white. So once again, the image is finished rendering. And now, as you can see, it's quite hard to tell due to the low resolution, but those pixels are white instead of green because this is a specular reflection, so it's picking up the specular qualities rather than the basic qualities. It shows, once again, the typical passes. The final section is quite short, it's just about external file handling. So the first test is testing that a final render can be output as different image formats. So typical would be JPEG, bitmap file formats. erroneous would be text or doc files, and extreme would be PNG files. For typical and extreme formats, the image should be saved to memory. For erroneous formats, the user should be prompted to save the image again using a different format. So I will simply use the scene we've already used with Greybox, and I will attempt to save it as test.jpg, which, as you can see, it has worked, and it gives me the image. If I do the same again with test.bmp, which is for a bitmap, again the image has been saved, and it brings it up for me. Now if I try to do text.txt, it prompts me to do it again, which I don't want to do. If I do test.doc, again, it just prompts me to do it again. I will note this is meant to prompt me to use a different image format, which it doesn't seem to be doing. And finally, test.png, the image has been saved, and again, it brings it up for me. I listed PNG as an extreme one as it is vector rather than bitmap, which JPEG and bitmap files are. So typical and extreme both pass. However, the erroneous did not prompt to use a different file format. And the final test is testing the mesh directory. Test if the program can create and access the mesh directory if the directory is not present in the same location as the program file, when the program should create the folder that it needs. So I need to stop running the program for this. If I go back to Visual Studio, you can see I have mesh.ply with the cube and icosahedron POI files from earlier. If I delete this, this is required for the code to run to import POI data. If I run the code again, you can see it has created that folder again. It shows that this test passes. Thank you very much. That is the end of the black box testing.